Hello friends, welcome to Code Sutra. In this video I will be talking about LeetCode problem number 875, Koko eating bananas. This is actually Koko, it's world's famous known gorilla. This gorilla actually changed the way that we look into animal intelligence. It was actually able to interact with other animals and also with humans with certain sign languages. So let's keep all these assets and get into the LeetCode problem. In this problem, you are given an array. What is this array? This array indicates piles of bananas. For example, in the first pile, there are 3 bananas. The second pile, there are 6 and so on. So, Koko now has to decide to eat these bananas, but it cannot decide a random number. It has to decide a number. For example, say it will eat 5 bananas per hour. Okay. It has decided it will eat 5 bananas per hour. So, how will it eat? So it will go to the first pile, it will eat all the bananas, then it is done with it. It will not go to the second pile. Though it can eat 2 more bananas, it will not eat from the second pile. Okay, so in the first hour, h is equal to 1. It just has eaten 3 bananas. Then we will go to the second hour. Then it will not eat all the bananas because the maximum it can eat is 5. So in the second hour, it will eat again 5 bananas. There will be 1 banana remaining. So again it will take 1 more hour to eat the banana. So in total it will take 3 hours just to eat the bananas from the first 2 piles. Again in the third pile it will take 2 more hours. Why? Because it will eat 5 and 5. Because the 2 bananas, again it has to take 1 more hour to eat. Then again it will take 3 hours to eat these bananas. Total it will take 8 hours to eat these bananas. All these bananas. So in this problem we are given a h and we have to find a k such that all the bananas are eaten within this hour and the value of the k has to be minimized. For example, we did it for 5, right? So let's do it for 3 and 4. If it is possible for 4, that will be our answer. If it is possible for 3, that will be our answer. But if it is not possible for 3, then 4 will be our answer. So we have to find the minimum possible k value. Okay. So what are the quick observations that we will be able to draw in this particular problem? The first observation, right? That is Koko has to eat at least 1 banana. Can all of us agree on this? Yes, right, because it has to at least eat 1 banana per hour. This is the minimum value that our k can reach. Our answer can never be lesser than this. It has to be minimum 1. What is the second observation that we can do? The maximum k value will be the max of this pile. For example, if the Koko decides to eat 15 bananas per hour or it decides to eat 12 bananas per hour, does it make any difference? No, right? Why? Because the maximum bananas in the piles is 11. So if it decides to eat 12 or 15, it doesn't matter because anything more than 11, it can only eat 11. So the answer can lie between 1 and the maximum of this. That is between 1 and 11. So this is one observation that we were able to draw. That is, we have a range in our answer. The answer will range from 1 to the maximum in the piles, that is equal to 11. So whenever we have a search space like this, or an answer space, that is our answer can have values from 1 to 11, we use something called as binary search over solution space. What do we do here? We pick up a random number, say for example 6. Once we have picked up 6, right, we check if it is possible with this particular number or not. For example, in this we check if it is possible with 6 bananas per hour or not. That is k is equal to 6. So if it is possible with 6, so can we safely eliminate all of these numbers? Why? Because if it's possible with 6, k is equal to 6, our answer will be 6 or lesser than 6. So can we safely eliminate 7, 8, 9, 10, 11? Yes, right. So that is the idea. And the second idea is, say we try to find it out by 4 and say it is not possible with 4. If k is equal to 4, if it is not possible, then is it required for us to check with 1, 2 and 3? No, right. If it is not possible with 4, it will never be possible with 1, 2 and 3. So that is the idea. So we pick up a number that is the mid of the range, and what do? We find out if it is possible with this k value or not. If it is possible, yes, the higher range will be eliminated and our answer will be updated. If it is not possible, then all the lower elements will be eliminated. So for this example, let's look at the check function. what does this check function do? It will return true or false, that is if it is possible with this particular k or not. For example, what it is doing is it is iterating over every element in the pile. It is iterating over every element in the pile, and what it does is for this particular value of k, it just divides the pile's element by k, and whatever is the ceiling value that will be there. For example, let's take 7, right? 7 divided by 5, it will be just 1, but we will take the ceiling value. So it will take 2 hours to complete eating this. Finally, we compute total hours required with this particular value of k, and if it is lesser than or equal to this particular h, yes, the gorilla can eat. If it is not, we will just return false. So that is the idea of this check function. So once you have this check function in this place, what do? We just check for every answer. For example, our lower range is 1, our high is 11. We find the mid. What is mid? It is equal to low plus high by 2. In this example, it will be 11 plus 1 by 2. So we will check with 6. Is it possible to do with 6? Yes, right? We already saw that it was possible to do with 6. So what do? We can safely eliminate all these numbers. So we can safely eliminate all these numbers, and our new answer will be 6. Why? Because it was possible to do with 6. Now, what is the range? So our new range will be 5 plus 1 by 2, that is with 3. So let's see if it is possible with 3. It will take 1 hour, then it will take 2 hours, total 3, then it will take 3 hours here, so total 6 plus 4, so it will take 10 hours. So it won't be possible with 3, so we can safely eliminate all the 3 of them, but in this particular case our answer will not be updated. Again we will check with 4 and 5. If it is possible with 4, we can safely eliminate 5. Yes, it is possible with 4, we can eliminate 5, and finally our answer will be 4, and we will return the answer. So this is our final function. Our left range or low will be equal to 1, and our right range or the high will be equal to the max of the piles, 11 in this particular case, and we simply do a check every time, that is we find the mid value, that is low plus high by 2, and every point we check. For example, we call this function and we check. If it returns true, we will just update our answer and also the range. And again, if it is not possible, again we just update the range, we don't update the answer. Finally, we will return the answer. And if you have completely understood this video, these are the problems that you can go and straight away solve. Find the solutions for this problem. All these problems follow the same approach, that is solution with binary search. Thank you for watching the video. Please do like, share and subscribe.